Quantum mechanics guarantees that the deeper you go, the more energetic nature becomes. It's for this reason that nuclear power is 1,000,000 times more powerful than chemical power. Why? Because chemical power represents a molecular manipulation. Nuclear power emerges from a nuclear manipulation, but the nucleus is 1,000,000 times smaller and 1,000,000 times more fundamental and 1,000,000 times more powerful than the chemical level. So the deeper you go, the smaller you go, quantum mechanics says, the more dynamic you become. The unified field exists at the ultimate scale of the Planck scale, 10 to the minus 33 centimeters.
The Planck scale is the very smallest level of reality. If we go down in scale, we're at meters, centimeters. If we go down to atoms, they're 10 to the minus 8th centimeters. Keep going down and down and down. Space-time is smooth until we get to the basement floor, the bottom level, where there's a pattern, there's a fabric, if you will, there's some kind of coarseness or irregularity, and that's at what's called the Planck scale, after Max Planck, the German physicist, at roughly 10 to the minus 33 centimeters, and the Planck time is 10 to the minus 43 seconds. So things are very, very small and happen very, very fast. Now, despite the fact that they're very, very small, space-time is everywhere, so the entire universe is created of this level.
Let's talk about the subatomic world, and then we'll talk about what it's telling us about reality. The first thing I want to tell you about the subatomic world is it's totally a fantasy created by mad physicists trying to figure out what the heck is going on when they do these little experiments. By little experiments, I mean big energy in little spaces and little pieces of time. It gets pretty nutty at that realm of things. And so subatomic physics was invented to try to figure that all out. We need a new science down there. It's called quantum physics, and it is subject to a whole range of debatable hypotheses, thoughts, feelings, intuitions as to what the heck is really going on.
The universe is very strange. There seem to be two sets of laws that govern the universe. In our everyday classical world, meaning at roughly our size and time scales, things are described by Newton's laws of motion, set down hundreds and hundreds of years ago. And they work very well for billiard balls and cannonballs and gravity. However, when we get down to a small scale, when we get down to, say, the level of atoms, a different set of laws take over. These are the quantum laws, quantum theory, quantum mechanics. And at that level, particles may be in multiple places at the same time. They may behave as waves smeared out spatially and temporally. They may be interconnected over great distances. They may be unified into one quantum state, into one state, governed by one wave function. And the borderline, the threshold, this curtain between the quantum world and the classical world is really mysterious. It's called sometimes the collapse of the wave function, because at the quantum world, everything is in superposition of multiple possibilities, and in the classical world, these multiple possibilities seem to collapse to particular definite choices. So everything is in one particular place. We were all taught in school that the world is made of stuff, of matter, of mass, of atoms. Atoms make up molecules, molecules make up materials, and everything is made of that. But atoms actually are mostly empty. For example, if this ball were the nucleus of an atom, a proton in a hydrogen atom, for example, then the electron circling this, which would describe the outer limits of that atom, would be out by that mountain over there, roughly 20 miles away. And everything in between is empty. In fact, the universe is mostly empty. However, when we go down in scale, in the emptiness, we eventually come to a level, the fundamental level of space-time geometry, the fine basement level of the universe, where there's information, there's a pattern. It's called the Planck scale, and it's the fabric of the universe. And at that level, there's information that's been there since the Big Bang. So most of the universe, even of matter, is actually empty.
The key underlying assumptions that most scientists still work under is that we live in a clockwork universe. We live in a mechanistic universe that is conceived of as gears and knobs sort of linking together. That is going to change because we know that that is not true. We know from a physics point of view it's not true. The impact of that change is still somewhat difficult to guess, but one of the areas that I know it's going to make a big impact is in how we understand the nature of human experience. Because human experience in a clockwork world doesn't fit. And that's why in mainstream psychology for many years, the very idea of an internal experience was considered to be laughable. There was no internal experience. It was explained away, and the reason it was explained away is because of this idea of living in a clockwork world.
Darwin countered. The Creator is nothing, nowhere. We are random mutations, simply a carrier of TNA's relentless quest for more in a meaningless universe. And meanwhile, both science and religion were hitting the wall. If everything was mechanistic and God was the holy creator, then what were we humans supposed to do? Science dug ever deeper into a dead universe and stumbled upon and unlocked a mystery.
In the material way of thinking, what happens is that we always shortchange ourselves because we cannot understand love, justice, or even meaning. So we think that the world is meaningless. Love and justice are figments of our imagination, which has no meaning in the first place.
It seems that on the one hand, say, physics is going to be urging that we look at people as if they were mechanical devices, and other kinds of discourses we have about love, about literature, about art, something like that, are going to be asking us to look at people in a very different way than that. And I'm interested at the points at which those two bang into each other. I'm interested in the points at which those two points of view that one can take on the world come into conflict with one another, come into collision with one another. And I'm interested in studying those collisions.
In tiny corners of space and time, scientists found unfathomable energy and mind-numbing mysteries. Mysteries that suggest we are all connected, that the physical universe is essentially non-physical. Time and space are just constructs of this non-materialness.
The question is, when you're studying the mind-matter interface, how do you go about studying it? From a naive point of view, you would think that maybe we should just get like a feather and see if we can make it float, or get an object and push it, something like that. The thing is, though, that happens so rarely. Even spontaneously, it happens extremely rarely. It basically never happens in the laboratory. So I think the reason that the mind-matter interface does not work very well on a large physical object is because that object has an enormous amount of inertia to stay where it is. You might be thinking thoughts at it saying, push, move, and it's thinking thoughts back at you saying, no, I don't want to. Or it would take an enormous amount of physical force in order to make it move. So back in the 1600s, when Francis Bacon was developing empiricism in science, he actually wrote in one of his books about ways of studying the mind-matter interaction and mentioned dice as a possibility. Because every time a die bounces, you can trace all the way down to quantum events which cause it to turn this way versus that way. So if it bounces a bunch of times, it basically becomes a quantum mechanical uncertainty, even in something as large as the die. So back in the 1930s, researchers started using dice as a form to see if mind can somehow get into the quantum uncertainty and bias what is happening in the die as it was rolling. Around the 1960s, when electronics came around, someone had the idea of simulating a die in electronic circuits. And the reason that became useful was because it became very easy to measure precisely what was happening in every single bounce or equivalent of a bounce. And you could record it automatically where you didn't have to worry anymore about whether the recording was correct or whether the die became unbalanced. So random number generators, modern versions of it, were created as a refinement of techniques that had been used in the laboratory for many, many years.
And could you go over some of your findings on that?
One type of random number generator experiment that's been conducted many, many times, hundreds of times, over the past 4 decades or so, since around the 1960s, has been a random generator that only produces sequences of random bits, zeros and ones, like flipping coins. And you would simply ask somebody to press a button, it would produce 200 bits. and you would ask them to say, well, try to make it produce more 1 bits than 0 bits. And when you take the entire body of literature, all of the hundreds of experiments that have been done, you can ask a single question. Did it matter that people were trying to push it towards 1s or push it towards 0s? And the overall answer is yes, it does matter. That somehow intention is correlated with the operation, with the output of these random number generators, such that if you wish for more 1s, somehow the generators produce more 1s. The last analysis that I did, which looked at all of these experiments, the final analysis is 50,000 to 1. The odds against chance are 50,000 to 1 that the behavior of the random number generators would go in the direction that they did, that were consistent with what intention was wishing them to do.
This leads naturally to wonder, are people affecting the world of reality that they see? You betcha they are. Every single one of us affects the reality that we see, even if we try to hide from that and play victim. We all are doing it.
Interested in the molecular structure of water and what affects it. Now, water is the most receptive of the 4 elements. Mr. Emoto thought perhaps it would respond to non-physical events. So he set up a series of studies, applied mental stimuli, and photographed it with a microscope.
For one sample of water, we drop about 0.5 cc's onto each 50 petri dishes. Then we take those 50 petri dishes and freeze them in a freezer at minus 25 degrees Celsius for about 3 hours. We take those frozen samples into a refrigerator that is set at minus 5 degrees Celsius, where a microscope with a camera is set up. There we take photographs of each of the 50 water drops individually. We first take photographs of water that we did not put any information in. Then we take the water with information and do the same procedure just described. We take those before and after photographs and compare the differences. When we projected the feeling of love and thanks to water, it made the most beautiful crystal. At times like this, I think water is at peace.
This first picture is a picture of water from the Fujiwara Dam. And this picture is the same water after receiving a blessing from a Zen Buddhist monk. Now, in this next series of pictures, Mr. Emoto printed out words, taped them to bottles of distilled water, and left them out overnight. This first photograph is a picture of the pure distilled water, just the essence of itself. These subsequent photographs, as you can see, are each different. This is the chi of love. And we move along here to thank you. And you can see where he taped that to this bottle here. But if you read Japanese, you already knew that. Now, Mr. Emoto speaks of the thought or intent being the driving force in all of this. The science of how that actually affects the molecules is unknown, except to the water molecules, of course. And it's really fascinating when you keep in mind that 90% of our bodies are water.
Makes you wonder, doesn't it? If thoughts can do that to water, Imagine what our thoughts can do to us.